So, good afternoon to all of you. I am Sulekha Saxena, Assistant Professor, EC Department, AKGEC, Ghaziabad. Today, I am going to cover a very important topic of Digital System Design course with subject code KEC 302. We will cover sequential circuit design in this lecture, and sequential circuits, basically we will cover synchronous sequential designing, which is also called as finite state machine. Before starting the designing of sequential circuit, first of all we will analyze sequential circuit. What is a sequential circuit? Any combinational circuit which includes memory element is called as a sequential circuit. That is, and memory element is basically a flip-flop. So, any circuit which consists of flip-flops is called a sequential circuit. Any sequential circuit, there are three terms, that is input, output and state. So, for analysis, the first step is the circuit diagram. Using this circuit diagram, we will find out the state or transition equation of the circuit. To find out the state equation, we should know about various types of flip-flop. So, we all know that there are four types of flip-flops available, that is D, T, JK and SR flip-flop. We have to know what is the state equation or characteristic equation of these flip-flops to design the final state equation. So, for D flip-flop, we know that next state Qn plus 1 is equal to, for JK flip-flop, the next state Qn plus 1 is nothing but J into Qn bar plus K bar into Qn. For toggle flip-flop, T flip-flop, it is T into Qn bar plus T bar into Qn. And we normally don't use SR flip-flop in sequential circuit designing because one of the input combinations generate invalid state. So, using these three equations, we find out the obtained state equation and the output equation. Then we formulate the state table or transition table, and using this table we find out the state diagram. We will take one example. Here the two D flip-flops are given in the circuit. In addition, there are certain logic gates. One input X is given, one output Y is given, and as there are two flip-flops, so there are two states in this circuit. Using this circuit, we can easily see that DA is given as A into X plus X multiplied by B. Using this circuit, we can see that this is A, this is X, and this is B. So, our equation DA is nothing but AT present state multiplied by XT input plus BT present state multiplied by XT input of D flip-flop is nothing but equal to input. So, AT plus 1 is equal to D is equal to AX plus BX. Similarly, next state of second flip-flop B is nothing but X multiplied by A bar. So, A bar T into X. We will also see that the output Y is nothing but X. This is given as B. This one is given as A and this one is given as X bar. So, A plus B multiplied by X ka bar. So, these are the state equation and output equation for this given circuit. Now we will formulate the characteristic table or state table using this state and output equation. The present state is given as there are two states A and B. So the present state is A, B and input X. As there are three variables, so we will formulate all the combinations from 0, 0, 0 to 1, 1, 1, and using the equation given above, we calculate the next state of AT plus 1, BT plus 1 and output Y. Similarly, when the input X is 0, A is 0. So, A 0, 0, 0, 0. When input is X is 1, then next state of A is A plus B. So, 0, 1, 1, 1. Similarly, for B, the output is A bar into X. For when X is 0, output is 0. So, 0, 0, 0 and 0. When A is 1, then also output is 0. So, this is 0, this is 0. And for remaining the output is, and for output equation, X bar into AT plus BT. When X bar is 0, that is X is 1. X is 1, output is 0. So, 0, 0, 0, 0. And when X is 0, X bar is 1, then output is A plus B. So, 0 plus 0, 0, 0 plus 1, 1, 0 plus 1, 1, 1 plus 1, 1. So, in this way, we calculate the next state and output using present state and using this table, we can formulate the state diagram. What are the characteristics of state table? State table is a multiple variable table wherein we formulate the present state, that is the value of A and B, input, that is the value of X, and using input and present state we calculate the next state using characteristic equation, that is A t plus 1 and B t plus. From the viewpoint of truth table, inputs are input and present state and outputs are output and next state. As we can see here, input are present and input and output are next state and output. So, we can redraw this table in another form, makes us state diagram easier. Present state, next state when input is 0 and next state when input is 1. Similarly, output when output is 0 and output is 1. So, present state has 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. When input is 0, what is the possible combinations of next state? And when input is 1, possible combinations of next state. Similarly, for equation Y, when x equal to 0, output, and when x equal to 1, these are the outputs. So, this is another form of state table, and using these, any one of these forms, we can easily draw the state diagram. Now, what is a state diagram? A state diagram can be seen as a graphical representation of state table. To encircle present state in it. Then a directed line segment from present state to next state shows the state transition, and each line segment is labeled with input and output variables for that particular transition. So, here there are 4 states, so 4 circles will be there, 0, 0, 0, 1, 1, 0 and 1, 1. So, we can say that for 0, 0 to 0, 0, input is 0 and output is also 0. From 0, 0 to 0, 1, input is 1 and output is 0. From 0 1 to 0 0, input is 0 and output is 1. From 0 1 to 1 1, input is 1 and output is, from 1 0 to 0 0, input is 0 and output is 1. And from 1 0 to 1 0, input is 1 and output is 0. We write the input and output above each line in oblique form. At last, from 1 1 to 0 0, input is 0 and output is 1. And from 1 1 to 1 0, input is 1 and output is 0. So this one will be the actual diagram. 0 0 0 1 1 0 1 1 labeling, and we see that for 0 0 to 0 0, input 0, output 0. For 0 0 to 0 1, input 1 and output 0. And similarly, for all the possible combinations from 0 1 to 0 0, from 0 1 to 1 1, input 1, output 0. For 1 0 to 0 0, input 0, output 1. From 1 0 to 1 0, input 1, output 0. From 1 1 to 0 0, input 0, output 1. And for 1 1 to 1 0, input 1 and output 0. So in this way we can draw the combined state diagram. So this is the overall analysis of any sequential circuit. The first step is to analyze the circuit, find out the number of inputs and outputs in the given circuit, then using a specific flip-flop characteristic equation, formulate the state equation and output equation. Then using state and output equation, formulate the state table. We can draw the state table in any one of these forms. It includes present state, input and calculate the next state and output. And using the state table, we will formulate the state diagram. In state diagram, within circle we write the present state, and present state to next state is marked using line segment with arrowhead, and above the line segment we write input oblique output. We take one more example using D flip-flop. Here the inputs are XY and there is one flip-flop, so single state A, present state is AT and next state is AT plus 1. So the next state, as we all know that for D flip-flop next state is equal to D. So AT plus 1 equal to A XOR Y XOR X. So for truth table or state table, we write in present state A input XY, and for this we write all the possible combinations from 0 0 0 to 1 1 1, and next we calculate the next state AT plus 1 for 0 XOR 0 0 XOR 0 0 0 0 0 0 1 1. So in this way we calculate all the next state values and then draw the state diagram. As there is only one state variable, so only two states will be there, and we have two circles 0 and 1. For present state 0 to next state 0, input may be 0 0 or 1 1. For present state 0, next state 1, input may be 0 1 or 1 0. For present state 1 and next state 1, inputs may be 0 0 1 1, and for 1 to 0 there will be 0 1 to 1 0. So this is the simple state diagram with only inputs and there is no output. Use another flip flop, that is JK flip flop. In this example, there is one input X, two states A and B. So we write here that JA is equal to B, KA is equal to B into X bar, JB equal to X bar. The characteristic equation of JK flip flop is J into Qn bar plus K bar into Qn. So the next state of first flip flop AT plus 1, K and Qn is output, which is A and B. J into A bar plus K bar into A, and BT plus 1 is J into B bar plus K bar into B. So we substitute value of JA, that is B into A bar plus K bar, that is BX bar ka bar into A. We open this equation, A bar B plus A B bar. For second, it is J, that plus K, that is A XOR B ka bar into B, which is nothing but A X B plus A bar X bar B. So this is the obtained expression. Now we formulate the state table where input is X and present state is A and B. So A, B present state, X input, and using this we will calculate the next state, that is A and B, using our equation. So we use all the possible combinations from 0 0 0 to 1 1 1 and calculate the next state A and B using the given equation. So the next state comes out to be state. As there are two states, so there are four combinations, 0 0 0 1 1 0 and 1 1, and only one input. So for 0 to 0 1 input is 0, 0 0 to 0 1 input is 0, from 0 0 to 0 0 input is 1, input is 0, for 0 1 to 1 0 input is 1, from 1 0 to 1 0 input is 1, and from 1 0 to 0 1 1 input is 0, from 1 1 to 0 0 input is 0, and from 1 1 to input is 1. So we write all the four present state, and in arrowhead as there is no output, so only input variable is written here. We will take one more example of this analysis using T flip-flop. For this given circuit, there will be two states, AT plus 1, BT plus 1, and one input, that is X. You can see from this circuit that TA is nothing but X multiplied by B. TB is nothing but X, and Y is equal to A into B. For T flip-flop, the characteristic equation is T bar into Qn plus T into Qn bar, that is next state Qn plus 1. So we can find out A t plus 1 is equal to Bx bar into A plus Bx into A ka bar. We can simply open this equation to find out B bar A plus X bar A plus A bar B into X and Bt plus 1 is equal to X XOR B. These are the next state. Also the output, final output Y is nothing but A into B. So using the next state and output and present state and input, we formulate the state table. Present state A, B, input X. Next state A t plus 1, B t plus 1 and Y. We will write all the 8 combinations from 0, 0, 0 to 1, 1, 1. And for these combinations, using the equation At plus 1, Bt plus 1 and Y, we calculate the values of next state and output. So we have calculated the next state equation At plus 1, Bt plus 1 and formulated this table using next state equation At plus 1, Bt plus 1 and Y, wherein B is equal to X XOR B, that is X XOR B. If both the inputs are same, output is 0, and if both the inputs are different, output is 1. So when one of the input is 0, output is 0, when both are 1, output is 1. And for At plus 1, we use this equation AB bar plus AX bar plus A bar BX. So for this, we write AB bar plus AX bar A bar BX to calculate next state. As once we find out the next state and output, we can simply draw the state diagram. There is one more way to represent state within the circle, like present state oblique output within the circle and input above the line. This is another way to represent. Input 0, output is 0. For 0, 0 to 0, 1, input 1, output 0. For 0, 1 to 0, 1, both are 0, 0, 0. For 0, 1 to 1, 0, input 1, output 0, input 1, output 0. For 1, 0 to 1, 0, for 1, 0 to 1, 1, 1, 0 to 1, 1, input 1, output 0. For 1, 1 to 1, 1, input 1, input 0, output 1, and for 1, 1 to 0, 0, input 1 and output 1. So in this way, we can simply design the state diagram of sequential circuit. We will move towards the Moore and Mealy model. Sequential machines are also called as finite state machines, and there are two types of model exist, that is Moore and Mealy. Moore model is named after E.F. Moore and in this the output are a function of state only, whereas in Mealy model it is derived by G. Mealy, and here the outputs are a function of input as well as state, usually specified on the transition arcs. So when we talk about the Moore machine, it is based on outputs only. So there is a combinational circuit, then flip-flop which is used to find out the next state, present state and then next state, and this present state is again passed through a combinational circuit to find out why. This is a Moore model. The output is not through flip-flop, output is through combinational circuit. So, in Mealy model, combinational circuit, then flip-flop. Till this point all the things are clear, present state and then next state, and input with logic combinational circuit is used to find out the output. So, final output is a function of state plus input in Mealy model, whereas in Moore model output is just a function of state. So, in Mealy model the output may change if input changes as we can see from here. If input changes, output changes. Also, output may have some false value because of delayed response from flip-flop. So, in order to synchronize Mealy type of, the input of sequential circuit must be synchronized with the clock and output must be sampled immediately before the clock pulse. Thus, the output of Mealy machine is present immediately before the active edge of clock. Now, I am talking about the Moore difference between Moore and Mealy state diagram. In case of Mealy model, it maps the input and state to output. So, the present state, then input oblique output to next state. Whereas, in case of Moore machine, it maps only the input above the line and output is with state. So, this is the difference between Mealy and Moore model. We will discuss regarding state reduction methodology also. First of all, what is the state or how two states can be same? If the output and next state for each of the values is same, then the two states are said to be same. For example, given the state diagram, we can see that A, B, C, D, E, F, G are 7 present state. Using the transition, we can simply write the next state and output. X equal to 0 and x equal to 1, we write the next state. For example, A to A for input 0 and A to B for input 1. Similarly, we write the present state and next state for all the inputs, and also the output for input 0 and 1. A to A output is 0 and for A to B also output is 0. So, we write the next state and output for each of the possible input combinations. And now we see how to reduce this table. As we can see, for E and G, whole row values are same. So, these, that is next state and output. So, these two states are equal and we remove or omit the last existing state in the table, that is omit the G. So, the reduced table will be A, B, C, D, E, F. Again we see that for D and F all the values are same. So, again we omit the last existing value, that is F, and the resultant D is equal to F. So, the resultant, and replace also in this table we replace everywhere where G by E, that is this value will become E, F by D. So, this becomes D, this will become D. So, the new table will be this one. Now, we see that all 4 rows are on, or the rows are different, and here this is the reduced state table, and through this table if we draw the diagram, then this will be the reduced state diagram for our given circuit. So, I hope this is clear to all of you. Thank you. Till this point we have covered how to convert our sequential circuit to state table, then state diagram, and how to reduce a state table and state diagram. In the next lecture we will continue about asynchronous state machine designing. Thank you all.